Hello and welcome to the Career Chronicles, where we unveil the passion, purpose, and parts of every profession. I'm your host, Jessica, and today we have the honor of speaking with accomplished astrophysicist Dr. Sabine Bellstedt. Join us as we dive into our journey, career development, the future of astronomy, and so much more. I'm Jessica, and you're watching the Career Chronicles.
Let's get into the questions. So would you like to introduce
I would
yourself?
love to. My name is Dr. Sabine Bellstedt. I'm an astronomer who works in Perth in Western Australia at the International Centre for Radio Astronomy Research.
Wow, very impressive. Let's talk about your background and how you achieved this career. What first inspired you to pursue astronomy?
I don't think that there was a single moment that I thought, astronomy is the job for me. I always just wanted, actually, no, that's a lie. I didn't always want to work in anything. I changed throughout my whole youth what I wanted to do in life. But I think by the time I got to sort of latter phase high school, I knew that it was science that I was most passionate about. And at some point, it was the way, the mechanics that science worked that particularly tickled my interest. And for me, that was mostly described by physics itself. And so I didn't know what I wanted to be other than that I would relish the idea of working in a field where you can apply science and learn new things. And in the realm of physics was particularly interesting. So I just studied a physics degree because that was what was interesting to me. And it was during the course of that degree that I came across astronomy, fell in love with that, and ended up in that direction.
Did you originally have physics as one of your subjects for high school, or did you
I
just,
did. I
yeah?
did. Yeah. So I mean, you can't do physics, at least because I grew up in Sydney. So I had a slightly different schooling system to the one that's in Western Australia.
Yeah.
But I did normal science all the way through until the sciences start to split, which for me happened in year 10, 11. And at that point, I did physics, chemistry, and biology, all three separately. So I did have a rudimentary understanding of physics from that point.
It's a lot of science you had. I could never.
But
Oh my gosh. That must have been so hard to study for all of those.
sciences are interesting because even though it's a lot of probably rote learning and knowledge, like many subjects are, the fundamental approach to studying sciences is quite similar. So it's maybe not as daunting as it seems, adding on more science subjects, because there is overlap.
Yeah. Did you have any role models growing up?
I had lots of people in my life that I was inspired by. And I had a bit of a think about this because the question of role models, um, it's an interesting one because I think different people look for different things in role models. And for me, it was important to be surrounded by people who were enthusiastic and broadly interested and could liven up the possibility of what my future would look like. I had um, a father who was an engineer, and so he was very engaged in STEM subjects generally. So I, from the home environment, had a very strong role model in the sense of STEM. I had a couple of amazing teachers who were just bubblingly enthusiastic about the science element that I didn't really get so much from home, because of course you need a broad range of people with interests to spark all of these things. And I remember there were a couple of little things like TV shows where there were specific people that I thought, you're amazing. And I don't know if you've ever seen the TV show Bones. Um,
I haven't. I'll check that
no.
out. Okay.
I watched it a lot when I was in high school, and the lead character in that is this amazing forensic anthropologist, and she just knew everything. And I would have loved to be like her. So lots of role models.
Go on to the education side of things. What skills or knowledge from your studies have been most valuable in your job?
It's an interesting question because it probably isn't what you might expect. So there were many, like we just discussed, I studied a lot of science subjects at school, and I went on to do a lot more science and mathematics at university. And while those sort of formed the technical foundation for the job that I have now, the things that I would describe as most important actually don't relate to that in many respects. So, for example, I did a lot of public speaking when I was at school. Turns out that's quite critical for a job in science where you have to communicate science all the time. Um, I did a lot of music, musical theatre, choirs, bands.
Oh, yes.
Surprisingly, yeah. And it's the kind of thing where you think, oh, well, that's a waste of time if you're interested in a career in science. Totally not the case. I think that teaches a level of confidence. It teaches a level of vulnerability. Sometimes you just have to put yourself out there and be comfortable with maybe not putting on your best performance and still doing it as well as you can. And I think that is an incredibly important skill that I still have to apply every day in my current job. I did, you know, various art subjects at school where any sort of artistic lessons I had at the time come through in the way that I present data in plots and the creativity of color use and all of that sort of stuff. So I think my summarized answer to that question is everything. Every skill has a different application, and those things that I spend the most time focusing on are those that I bring forward in my current job the most.
Can I ask really quickly, what instruments did you play?
Very early on, I played the piano, but the instrument of focus was the flute, which, funnily enough, I picked after many, many years of not picking up the flute at all. I picked it up 2 years ago, and I've joined a very, very average community orchestra now in my adult life. And it's a wonderful way of bringing music back into my life, which I think is critically important, actually.
I love that. That's really cool. So, are there any specific subjects or topics you recommend students focus on to prepare for a job in astronomy?
Mm. As far as the actual technical skill sets themselves, the three that I would say are pretty key, I would say, are physics in some form. You can probably get a pretty good understanding of the basics in astrophysics through chemistry as well. So chemistry was never the aspect of science that was what I was best at. So I came in with a physics attitude, but you can absolutely come in through a chemistry side as well. So both things are important in different ways. Mathematics, it's always important, at very least the basic things. And if anyone has an opportunity to study it, any sort of programming course
Yeah.
is what most of us in astronomy spend most of our time doing. I didn't do it at school at all. I, in fact, didn't even do it until the very later phases of my university degree. So I was very late to the game. But for anyone who gets the opportunity now, get coding as early as you can because that's becoming only more and more important.
What coding language do you use?
So on a day-to-day basis, I use two separate coding languages, Python and R. Depending on the kind of astronomy things that you do, you might want to use different languages. So R and Python are both what we call fairly high level, which means you write them much more like normal languages. And that works perfectly for the sort of analysis applications that I have to use. But if I were a kind of astronomer who does much, much bigger simulations, then they use much more what they call low-level languages. So I have a lot of colleagues that use C, C++, a lot more strongly than R or Python.
In your code, how much works? Because when I do coding, half the time it's all just errors and I get so frustrated.
That all of us, every single person that I know who codes has the same problem. I was just chatting with some colleagues this morning that if we ever have code that we write that works the first time around, we're almost worried about this. It's like, what errors haven't been registered by the code that are actually in there? So yes, I think that's quite normal, no matter how good you get at it.
Did you partake in any extracurricular activities, internships, or programs like that in high school?
Not as many as you might imagine. So I had oodles and oodles of extracurricular activities in general, but most of those weren't science focused. There were a couple of clear activities that I participated in that definitely opened up the world of science to me. I remember when I was, I think, in year 10 or 11, there was a science experience that was being held by one of the universities in Sydney. And for about a week, we would go all day into the university and have a hands-on experiments and classes and interact with some of the uni students that were doing science that was well ahead of anything that I had come across with at that time. That was very exciting. And in which year was it? Year 11. I had the incredible honor of being selected as the female representative at the International Space Camp in the US, which was phenomenally exciting. But I think that was one of the first times that the idea of space properly came across my desk because, like I said, at this point, I was just interested in physics in general. And all of a sudden we were doing rocket equations and trying to build our own rockets and learning about the space race and working within the realms of NASA. So it wasn't many things that I did, but those couple of experiences that I managed to get my hands on were pretty amazing.
That's so cool. Oh my goodness, that must have been such an amazing experience. That's really
It was
cool.
pretty great. Yeah. And you meet some very interesting people doing these things outside of your normal classroom environment too, which is very valuable.
Did you go to the University of UWA to study for astronomy, or did you go to another university?
I didn't. I actually, because I grew up in Sydney, I went to a university that was a couple of hours south of Sydney called the University of Wollongong. And that's where I did my undergraduate degree in physics. I the only reason I really picked that degree was because it had a very public physics course. So I could see a listing of all the physics courses that were going to be in there. And I found that incredibly exciting. And then when it came time to do my PhD, which happened later, then I moved to Melbourne for the Swinburne University of Technology. And it was only after I finished that that I then popped over to Perth and am now at the University of Western Australia as a researcher.
Nice. How's University of Western Australia? Is it good?
It's beautiful. I think it's one of the most beautiful campuses in Australia, and I've been to a couple now, and UWA is a pretty good one. And it's in Perth, which is a fantastic city, and there are lots of opportunities. So I love it here.
Okay, let's move on to your career development. What's it like being a woman in STEM?
It's liberating and challenging at the same time, is the way that I would describe that. I think in the current era, it's the best possible time to be a woman in STEM. I think a lot of us are aware of the fact that in the last couple of decades, it's been a tough place for women, especially because there weren't many of them. And that is slowly starting to change. So in my group, it's still definitely male dominated, but I have met female colleagues. And more importantly than that, the contributions that women make, I find, are valued within the community. And that's an important thing, because even if you are the only person in a room of a particular demographic, if at least the contributions that you make are valued and listened to, that makes that a lot more bearable. So there are things that I do differently because I'm a woman, and that's a good thing. So I see that as an asset because I can bring something to the table that sometimes my male colleagues wouldn't focus on. It does come with its challenges though, because sometimes I'm in meetings and I'm the only woman in the room, and my brain might work a little bit differently in that moment, and that's something that I have to learn to deal with. But I would say it's not all gloom and doom, and it comes with some significant benefits as well.
That's good to hear. That's really reassuring. So, I've read your work on galaxy evolution and star formation. It's very interesting. Do you think you could explain it in a way that our teen magazine audience can understand?
Oh yeah, I'd definitely love to try. I work in what they call galaxy evolution. So we all live within the Milky Way, which is just a singular galaxy. But out there in the universe, we've got something like 100 billion other galaxies. And I call it space epidemiology a little bit. If you want to understand how humans work and how we, operate health-wise, it's not very helpful to study just a single person. That tells you a lot about the anatomy of specific organs. But when you want to understand how, for example, something like COVID impacts people across the world, you really want to understand people of different demographics, people of different ages, people with different genders, people who live in different parts of the world and with different life conditions. With galaxies, we've got so many different galaxies and they all look a bit different. There's an incredible variety of different galaxies out there. And for us to build a cohesive picture of how that's happened over the 14 billion years of time, which is a long time, we're in a regime now where we don't just want to study individual galaxies. There are still people who do that, but my focus is very much, let's look at massive samples of galaxies so that we can understand the statistics of how that's happened. Now, in astronomy, we've got the incredible privilege of being able to literally look back into time, because the farther away we look, the farther back in time we look, simply because the light that's come from that source has taken time to travel. And so by the time it gets to us, we're seeing the object as it was billions of years ago. So we have this wonderful challenge that I think no other science has, where we can piece together massive samples of nearby things, so the current universe, all the way through to the distant universe where we're looking at history, taking those static snapshots of galaxies and trying to build models and understanding of how that's moved. And so that's exactly what I'm in big teams trying to solve.
How does your research help us understand the universe?
So there's a lot that we don't yet know about the universe. And the interesting thing with that is that it's a field that is pretty much there entirely for our own curiosity and for putting us within the context of where we live. So some people might argue that understanding exactly what the beginning of the universe looked like doesn't impact our day-to-day life on Earth. And that might be true, but at the same time, it fuels that part of us that just yearns for knowledge and greater context. And that's what we call blue skies research in the academic world, where sometimes you just want to solve a problem for the understanding of what's going on. And so that's what we're really striving toward when it comes to things like the expansion of the universe because of dark energy. We've got no idea why that's happening. When it comes to dark matter, there's like an enormous amount of mass in the universe that we just don't know what it is yet. Those are sort of the two headline arguments. And then there are all these other phenomena going on in space that we don't really understand. All of those aspects of astrophysics and cosmology that are trying to answer these questions often use galaxies as traces for what's going on, or they use them to understand the large scale structure. And so having really cohesive backbone to understand exactly how that skeleton has come into place is then the bedrock with which to answer the bigger questions in the universe.
Let's move on to the future of astronomy. So, how do you see the field of astronomy, astrophysics moving forward in, say, a decade?
It's a very interesting time because I think astronomy, which many of your readers may or may not know already, is one of the oldest sciences in the history of humanity. I think since we were popped out onto this earth, we've been looking up at the sky and wondering, what is that? And that has been astronomy. And so it's interesting to think that the oldest science in our history is actually one of the ones that we still have so many questions after all of these thousands of years of study. I think astronomy, the way that we know it now, has really been done in earnest in the last 100 to 200 years only. And for the longest time, that was individual astronomers looking physically through a telescope and making notes and trying to understand the universe that way. And that's probably the image of astronomy that most people have in their mind. And that's just no longer how astronomy is done. The scale that we need to understand the outstanding questions doesn't come from a single night looking through a telescope. So we now have massively big pieces of infrastructure. People might have read about the James Webb Space Telescope, for example, which is now 1 million kilometers out in space, and it took $10 billion to fund that. So these are massively expensive pieces of kit, but they have the capacity to look into the outer reaches of the universe. So that sort of astronomy requires enormous levels of funding, as many things do, but also huge groups of teams and people working together to make big projects happen, because it's those big projects that work beyond. We've got one of those happening in Australia as we speak, the Square Kilometre Array, which is very, very exciting. So that's just started construction in Western Australia. And these are the types of projects that have been under planning for over 20 years already. And construction will take many, many years. And then probably by the time we get to the end of the next decade, only then will we start to analyze the data that have come from these facilities. So what astronomy looks like in the next decade is massive projects and large teams of people that can really contribute different, diverse skill sets to try to extricate masses of data and the deluge of information that we will get from those.
Wow, thank you. So, do you have any upcoming projects that you are excited to work on?
We always do. The one thing about astronomers is that we get too excited and we build lots and lots of future projects, and then we get too excited by many of them. There's one that I'm working on at the moment, which is much closer to Earth than many others that we're doing. But there's a relatively little telescope in Chile. So it's by little, I mean, it's a 4-meter diameter mirror. And it's getting a revamp. from just being an imaging facility, so one that takes pictures of the sky, to one that can measure thousands of spectra of objects at once. And by spectrum, I mean when you split up the light of a source into its different wavelengths, and you can really see the chemical signatures of what's going on out there, which gives us an absolute wealth of data to work with. There's a specific survey that's going to be done with that telescope, hopefully starting at the beginning of next year, that will measure the distances with those spectra to about 2 million galaxies. That will be the densest and most complete, as we call it, sample of galaxies that we have to date. And I'm very excited to not just be building that survey and to working on it, but then to eventually start doing science on it. Oh,
That's so cool. Oh my goodness. That's so exciting. I can't wait to check that out. Okay, so I got this question from one of our teen magazine writers. She's very interested in astronomy, and she asked me to ask you this. Do you have any thoughts on humans on any other celestial bodies other than the Earth and the Moon?
humans, as in the humans that have come from Earth, or whether there could be some parallel evolution of humans that have popped up outside of our own celestial environment.
Let's go with humans on Earth.
I think it's an interesting phase now because politically, at least, there is genuine discussion about humans exiting our local sphere. So there's the Artemis mission in the US that is at least trying to get to the moon, which once we've got back to the moon, that is a massive leap, to use words of the past, for all of us as far as making that more normal. But there's also a lot of discussion as far as moving to Mars. Because these are things that people get excited about, and for good reason, I would say, I think genuinely within our lifetime, we will see people doing interplanetary travel. Will it ever be a normalized, everyday person thing? I suspect not. Will it mean that certain elements of science and communication from places other than the Earth will become more prevalent? Yeah, I think so. That's a pretty exciting thing to think about.
Yeah. So, lastly, do you have any tips for teens interested in pursuing astrophysics, astronomy, and other careers in that field?
I absolutely do. And the biggest tip that I could give anyone is find the things that you find interesting, find the things that you are interested in learning more about, and pursue that. If that happens to be astronomy and astrophysics, there are so many different communicators that try to share what it is that they do on a daily basis. Find them and reach out to them. It's amazing how much you can do with just a communication. And in the era of social media where people are ready to tell the world what they're working on, absolutely engage in those conversations because you'll learn a lot from that alone. The other thing to keep in mind is that there are now so many programs that departments and universities offer where they try to have either camps or internships or sessions where it might take a bit of Googling in the particular places where people are to know what's happening locally. But the opportunities are there, and we would love for anyone interested in the field to reach out and say, I want to learn about stars or fast radio bursts or galaxies, and the opportunities probably exist. I think astronomers are much more willing for people to approach them than many people realize. And even if you're interested in astrophysics and the prescribed path seems like something that's not really what you're interested in, I would say always more important to do the thing that's interesting to you. And down the line, it's incredible how many of those skills can be curated into a career that you are best at.
Thank you so much for doing this interview with me. Lastly, do you have any final words you want to say to our audience?
Pursue your passions, be interested, and have your eyes open for the opportunities around you. And I think that will set you in good stead, regardless of what it is you want to do in the future, whether it be astrophysics or any other regime of career. Wonderful. It's been lovely speaking with you, Jessica.
Thank you. That was so well said.
And with that, another fantastic episode of the Career Chronicles comes to an end. I hope you enjoyed Dr. Bellstedt's story as much as I did. Don't forget to tune in next time as we continue to unveil the passion, purpose, and paths of every profession. Until then, I'm your host Jessica, and this has been the Career Chronicles. See you next time. Bye!